So what's the input? Well, Lasgrid does not use neighbor information, so we can use the unbuffered. The unbuffered and of course normalized. And that was stored in here. We used that earlier for last canopy. So again, I browsed to the directory called height normalized and unbuffered. And I want to use pixel size. The same pixel size we used before. Which pixel size did we use for the last attempt? Yeah. Sure. I mean, for the last attempt, I don't remember I changed it. Did I change it for you? Okay. Let's use the same one then. And now for every pixel in here is the operation I talked about. This is the operation. I can keep the lowest or I can keep the highest. So this is now telling each pixel as your points drain on you, only keep the highest. Of course now the elevations are actually not elevations. The elevations are height above ground because we have normalized input. But it's stored in the elevation field, in the Z coordinate. And now we want to actually make something we can look at. We want to make an image, a colored image. So we want to apply a color ramp. And if you don't specify what the colors should be, it will go from minimum to maximum. Now we want to set the maximum. What's the maximum tree in there that we should care about? I maybe ask the person who knows how high the trees are. Well, we see the natural growth that was up to 4.6 meters, right? Yeah. So, but we don't care so much about it. So maybe 40 meters. Or 35.
So what is the final? What is the influence of this?
It goes from blue, 0, through various shades of green and orange and red to red. 40. I mean, you should really focus on the area that's of most interest. If the old growth is not interest, then so much then. That just becomes all red. Okay, 35. You can do it twice until you have the right setting. Just remember what the setting was. Maybe code it into the name of the output. Now, Lasgrid is also fairly can handle a lot of points because it doesn't do a very complex operation. So we can also afford to merge it all into one. And the output, we want to put in the same directory where we put all the other outputs, in the main directory. And now we get it in a picture, so we call it CHM. And maybe so we know what the colors mean. 0, 35.png. This way, if you see, now you know. But if in 6 months you look at this, yeah, what was red again? Was it 30, 35, or 40? I know we mentioned all three numbers. Now I know it's 35. When we do the operation IS, of course, there's one important thing we need to do. Anybody off their mind can think of what that is? load do you want to use the highest? I heard it. Noise. Oh, there it was, behind the screen. The noise. So we want to drop the noise points. Drop classification 7. Otherwise, you'll get the occasional pixel which is very bright red in the middle of the forest. So let's run it like this first, for auto-format PNG. Fine. A quick review, Lasgrid. The unbuffered height normalized tiles, I merge them all into one. I drop classification 7. I take a step size of 0.5 meter. I keep the highest Z coordinate, and then I apply a false coloring. If the highest Z coordinate is 0 or lower, it's blue. If it's 35 or higher, it's red, and anything in between will be a scaling. And the result will be stored in this output directory with this file name. Start. Am I done? Yes? Oh, it's a big image. 31 megabyte. Double clicking, and hope I won't crash Google Earth. Go. Maybe I turn off the contours. Oh. Then I'm zooming in. And you see a few empty pixels. Here, these empty pixels, you see the DSM, the DTM shining through. That's why it looks gray. Below us is the DTM. I can turn off the DTM. And then you see the Google Earth imagery. Oops. So, yeah, you see, just using Lasgrid isn't quite really super pleasing. The red is 35 meters or higher. So that's the old growth here, really high. And so blue is low, yellow and orange is fairly high. And every time we get to the old growth is always the highest. I'm not changing anything except the name. I maybe add, just so I have a different name, I add that I use a disc of 20 centimeters. Yeah, I'm dropping now discs of 20 centimeters instead of points. And then I need to specify this directly in the command line. So I have the new name, disc of 20 centimeters. At the very end, I'm over here now, I add minus sub circle, one word, O.1. So this is a radius, so the disk will be 20 centimeters in diameter. And now I'm repeating it. Now 20 centimeters discs for a grid size of 50 centimeters should make quite a difference. Right? Because the likelihood that I'm at the edge and with my 20 centimeters will reach another disk, another grid cell is fairly high. if I have a very big grid cell, like a 2-meter grid cell, then most of the points are falling far away from the boundary, and the disk won't do so much. But I would expect a big. Most of these empty pixels should be filled now. Not all of them. There will always be some place where the point distribution is just really bad and it didn't get sampled well by all these flat lines. Alright, I don't want to do much more. I want to look at the result, and hopefully the result is so good. Hello? Oh, yeah. And hopefully, was it off the entire time?
No, it was, I put it off.
Okay, I was thinking now we're using the whole time. Let's look at the result after turning the points into little circles, into little disks. So here's the previous result, where we see all these little empty spots, and we see a lot of pits. Pits is what we call, when in the middle of the canopy I have this blue thing. This is similar to the spikes, but for a different reason. There was just no point nearby that would cover that up, because we're not interpolating. We're just dropping the points onto the grid. And of course all the gray ones, which are empty. So let's look at the new one. There was this one here with disks are 20 centimeters. Oh. And zoom back in. And now we can compare those. And you see what happens? We closed a lot of these empty pixels, and we closed a lot of the other things, but still, there are still empty pixels, and there are still a few pits. Here's one of those pits we didn't close. We closed a few others, but not this one. And here is still an empty pixel, 2 empty pixels actually. Here's 2 empty pixels. But you know, if you want to make a publication, that's probably good enough. There's one more option you can use to get rid of the empty pixels. It's called fill. If you put a minus fill 1, after there are any pixels left now, it'll just look at the neighbor ring and then just fill it with the average. And for a publication image, that's probably good enough. Or you make the disk even a little bigger, 30 centimeters. That's a very fast and very, very easy way to make a CHM. But you still see here there are some issues. It goes from red all the way down to blue. There are pits in here, here and here and here. But compared to what we had before, it's a lot better by taking disks instead of points. So this is a technique I use to make a quick picture that looks good and doesn't take the same amount of time like the pit-free algorithm. But if I wanted to do a really good one, I would use the spike-free or the pit-free algorithms.